So let's talk about how we apply Pythagoras' theorem. So we've learnt how to use Pythagoras' theorem to find, our longest side, the hypotenuse, and the two shorter sides. But we use it to solve other problems. Okay, so here's a question from a Year 12 exam. Now, question 1 means it's going to be the easiest question. Henry flies a kite attached to a long string as shown in the diagram below. The horizontal distance of the kite to Henry's hand is 8 meters. The vertical distance of the kite is 15 meters. The length of the string in meters is. So we have to find the length of that string. So if I labelled them A, B, C, C squared equals A squared plus B squared. C squared equals 15 squared plus 8 squared. So C equals the square root of 15 squared plus 8 squared. Let's get my calculator up. So 15 squared plus 8 squared. So C is the square root of 289. So square root of that is about 17 meters. Okay, 17 meters. And yes, that's the correct answer. But a lot of students put 289. A lot of students put 23. 23 is just those two added up, isn't it? Yes, this is a Year 12 question. Another Year 12 question, this time from the 2012 multiple choice ones, question 3. So we've got these two trees on horizontal ground. So a 25 metre cable connects the two trees at point A and B as shown in the diagram below. So you can see here we've got the cable, 25 metres. You can see point A there, point B there. Point A is 45 metres above the ground. And point B is 30 metres above the ground, as you can see here. The horizontal distance in metres between point A and point B is. So, given this, I've got to figure out, it's badly drawn, but that distance there. So, you can imagine this like that. Point A, point B, 25. X. Now, I know what you're thinking, but miss, we don't know that. But we do, don't we? We know B is 30 metres above the ground. A is 45 metres above the ground. So this distance here must be the difference between B and A. So that's 15. Okay, so we've got C squared equals A squared plus B squared. So that's 25 squared equals 15 squared plus X squared. So X squared equals 25 squared, take away 15 squared. Okay, so let's get our CAS back up. 25 squared, take away 15 squared is 400. So X squared is equal to 400. So X is equal to the square root of 400. Yep, and that's 20 meters. Okay, so that one there. Now you can see all my workings out there. The x squared is equal to 400. So x is equal to the square root of that, which is 20. So you can see how I wasn't given just the triangle there. I was given it in this world context, in this real world context, and I found the triangle. So I did the exact same procedure as I was doing, back with our other triangles. I drew the triangle, I wrote the formula, I substituted in my knowns and unknowns, I transposed it to make the unknown the subject, and then I solved it, just like what we were doing before. I made this complicated diagram into a nice simple right-angled triangle. So using composite shapes is when we have shapes that are made up of other shapes and we use our shape knowledge to work things out. So here we want to find the value of x to 2 decimal places. So we have here a trapezium, and the other way you can think about a trapezium is as a rectangle and a right-angled triangle. So we know the 2 parallel sides and that side there, but we want to figure out the length of that side there. To do that, we can think about this again as being a rectangle and a right-angled triangle. Let me redraw that triangle. Obviously not to scale. Like so. Now, as we know, that's 20 centimetres there, that's 25 centimetres there. That length there, that there, is the difference between them, which is 5 centimetres. So, looking at this, that side, which is this, is the same length as that, isn't it? Because we have a rectangle there. So, that I can label as x. So, first off, I'll write my Pythagoras theorem formula. Then I'm substituting my knowns and unknowns. So 8 squared equals 5 squared plus x squared. Transpose it. So x squared equals 8 squared, take away 5 squared. Okay, I'll get my calculator. So 8 squared, take away 5 squared. So that means that x squared is equal to the square root of 39. And if you're asked to find, so x is equal to the square root of 39. X squared is equal to 39, so x, just x itself, is equal to the square root of 39. Now if you're asked, I might just rewrite that. Yeah. Okay, make it a bit clearer. Equal to 39. So x is equal to the square root of 39. Now if you were asked for exact value, you'd leave it as that. But because we're asked to 2 decimal places, we'll work out what that is. Okay, so get that. Square root of 39. Approximate, so that is 6.245. And it's to 2 decimal places. So then I look at that and go, okay, that's 5 there, so that makes that round up. So x is about 6.25 centimetres. So here we have to find the value of n to 1 decimal place. Now you can see here we have a triangle, a scalene triangle, because all the sides are different lengths. Now I've already put in our little dashed line here to give us the clue that we have 2 right-angled triangles that make this up. And I know that that length there is 2 meters, that length there is 10 meters. Now I've got that length there is 7. Now to then work out what n is, I need to know that length. Okay, so I'm going to have to do a couple of steps here. Okay, so I might just like that. That 2, 7, and I'll call that x. Okay, so our Pythag formula squared, so that's 7 squared equals 2 squared plus x squared, so x squared equals 7 squared, take away 2 squared, so x squared equals, okay, so 7 squared, take 2 squared equals 45. So that means x is equal to the square root of 45. Okay, which is about 6.71. Now, let's come to look at finding n. Running out of room here, but that's okay. I'm just drawing the triangle again. Okay, so I've got n, 10. Now that's x there, which we've just worked out, 6.71. So c squared equals a squared plus b squared. So that's n squared equals 10 squared plus, well, x squared, which we've just worked out over here. Oops. And x squared is 45. Okay, so I'm going to come here and go 10 squared plus 45 equals 145. So n squared equals 145. So n is equal to the square root of 145. Okay. So n is 12.0416. And our rounding instruction was to 1 decimal place. So I tried to not round until the very end. So 12.0. Now even though that's a 0, because it says to 1 decimal place, I have to put that in there. Okay? I have to show that correct units. So when we're looking at three-dimensional figures, three-dimensional shapes, you might be able to see many different right-angled triangles. So this is where drawing the diagram and drawing the pictures really helps you. So I've got this question from question 4 in the textbook. Calculate the length of the longest metal rod that can fit diagonally in each of the boxes shown below. Give your answers correct to 2 decimal places. Okay, so let's look at this first one. So we have this rectangular box and we need the longest metal rod that can fit diagonally. Now, looking at this, it's going to be from that top corner here to this bottom corner here. That's diagonally. Okay. Right, get another colour so it shows up a bit better. There, like that. Okay. Now, AB. Now there's a bit to find there because we can see, okay, this triangle that we're making here, its bottom is like that. If I label that C, we can see that there's that triangle. Okay. Do that again. Nope. Okay, A, B, C. Okay, and we know that distance there. We don't know that distance there. Okay, if I then look at the one we do know, I'm just drawing the triangles. We've got 15, it's B, C, 19.5. Okay, so I can find that length CB there and use it here to find that length that we really want there. Okay, so I'll label a few of these. I'll label that M and X. How's about that? Okay. Now I've labelled both of these X because they're the same side, aren't they? They are the same side. So let's start off with our Pythagoras theorem. So C squared equals A squared plus B squared. Now I have to start off with this one, don't I? So here, that's X squared equals 19.5 squared plus 15 squared. So X squared equals, let's get our calculator, 19.5 squared plus 15 squared. So X squared is 605.25. So that means square root is about 24.60 to 2 decimal places if I was doing that. Makes it easier to write, but in our calculator we can use the full answer. Okay, so now let's look at this next one. Let's write that out. Okay, so C squared equals A squared plus B squared. So that's M squared equals 18 squared plus X squared. Now we figured out that X squared is 605.25. Okay, so M squared equals 18 squared plus 605.25. So M squared equals, okay, so 18 squared plus X squared, 605, equals, so M squared is 929.25. Of course, we want the square root of that. For M, okay, like so. And so M is 30.4836. And x to 2 decimal places. So looking at that, that means m is equal to 30.48 centimetres. Okay, so you can see that same procedure, but here I had to do the 2 right-angled triangles to figure this out, because I needed to figure out that length, that CB, in order to figure out that AB. Okay, so I've had to draw the 2 triangles there, and I've done my 2 blocks of working out there.